Welcome to another episode of Environmental Digest. Today, we are going to talk about the hidden physical world behind artificial intelligence. Yeah, we're going to pull back the curtain on AI and reveal something you might not think about: its massive physical world and the immense environmental cost that comes with it. You know, we've all heard it. We talk about AI and machine learning like it all just happens in the cloud. It sounds so ethereal, right? Kind of weightless and digital, almost magical. It gives you this image of our data and these crazy, powerful models just floating around in some abstract digital space. But have you ever really stopped to think about what's behind that cloud? I mean, what's actually holding it up? What's the physical reality behind all that digital magic? Well, the truth is, behind every single search, every single AI prompt, there's a colossal, uncompromisingly physical infrastructure. It's a massive energy-guzzling industrial process. We're talking about acres and acres of steel and concrete data centers, huge electrical grids, and just a voracious appetite for the planet's resources. Turns out the cloud is very, very firmly planted on the ground. So, in this first part, let's really peel back that digital illusion and start to calculate the true physical cost of AI's insane expansion. Okay, so this whole environmental footprint really boils down to three main things. First, there's the massive energy consumption. Then, you've got this hidden water footprint that most people never think about. And finally, the entire life cycle of the hardware itself. Let's kick things off with energy, because the scale here is, well, it's staggering. Some projections suggest that by 2030, maybe 2035, data centers, which are being pushed harder and harder by AI, could be eating up to 20% of all global electricity. I mean, just think about that. 20%. That's a mind-boggling demand on our power grids. And it's not just about power. All that energy creates a ton of heat. So to keep these giant server farms from literally melting down, they need massive cooling systems. And guess what a lot of those systems use? Water. Millions and millions of liters of fresh water, putting a huge strain on local resources. It's a direct physical impact that we just don't connect to our digital lives. And then there's the actual hardware, the stuff AI runs on. Get this, in 2022 alone, the world generated 62 million metric tons of e-waste. And the pace of AI, which just constantly demands newer, faster, more powerful chips, well, that's going to make that number climb a whole lot faster. Now, this is a really crucial point. The environmental hit doesn't just start when a server gets plugged in. No. It begins way, way earlier, at the very beginning of the supply chain. We're talking about the moment raw materials get ripped out of the earth. This table really lays it all out. To build the high-performance GPUs and the batteries that AI needs, you need a whole bunch of critical minerals. And as you can see here, digging up stuff like gallium, lithium, or cobalt, it comes with some really heavy costs, both for the environment and for people. We're talking about toxic pollution, massive water usage in places that are already dry, and serious human rights risks. Okay, so once those minerals are mined, they head to these places called semiconductor fabrication plants, or fabs for short. And these places are, wow, they're some of the most resource-intensive industrial facilities in the entire world. They use unbelievable amounts of energy, ultra-pure water, and a whole cocktail of chemicals just to make a single wafer of chips. So what that means is there's this huge environmental cost that's already embodied. It's locked into the hardware before a single server is ever even turned on. And that brings us to the other end of the story, the incredibly short life of this hardware and the e-waste tidal wave it's creating. So here's the real engine driving this whole e-waste problem. The actual technical lifespan of a top-of-the-line AI chip, it might only be, a year and a half to 3 years before a newer, faster one comes along and makes it basically obsolete. This just creates a relentless cycle of rip and replace, generating actual mountains of electronic waste. And this chart here really drives home why that is such a huge problem. Look at this. A whopping 40% of a chip's total life cycle carbon footprint comes just from making it. So when we toss that chip out after just a couple of years, we're literally throwing away that massive upfront environmental investment. And to make things even worse, we're not getting these materials back. The global recycling rate for all e-waste is less than 20%. For the super complex specialized parts in AI hardware, you can bet that number is even lower. So all these valuable and often hazardous materials are just gone, lost. Look, The scale of this challenge is, yeah, it's daunting. But this path we're on, it's not inevitable. We can change it. So what does a path towards a greener AI actually look like? Well, there's a growing movement inside the industry to tackle this, and it's called green AI. The core idea is actually pretty simple, but it's really powerful. We need to shift our thinking and make energy and resource efficiency a primary goal in AI research and development, not something we just kind of worry about later. And a huge piece of this puzzle is moving away from our current economic model. Right now, we're stuck in a linear economy. You know the drill: take, make, dispose. The goal is to shift to a circular economy, a system that's designed from the ground up to reduce, reuse, and recycle. And this isn't just some fuzzy, abstract idea. There are concrete strategies we can use. We're talking about designing hardware for longevity and repair, so you can upgrade it instead of just tossing it. It means using recycled materials to build new hardware, and it also means making the AI algorithms themselves way more efficient, so they just don't need as much raw power to run in the first place. Oh, and developing standardized carbon reporting so we actually know what's going on. So all of this really brings us to a fundamental choice, doesn't it? A choice about the kind of future we want to build with this incredibly powerful technology. There's a great quote that I think just sums this up perfectly. AI is an amplifier. It amplifies productivity, it amplifies creativity, and right now, it is absolutely amplifying energy consumption. Whatever we point it at, it just makes bigger and more powerful. But the thing is, that trajectory isn't set in stone. It's not predetermined. We are making choices right now, every single day, that are shaping its future. So the final question this all leaves us with is, what will we choose to amplify? Are we going to keep magnifying this unsustainable model, or are we going to use this incredible tool to amplify efficiency, ingenuity, and a much healthier relationship with our planet?